You're traveling through another dimension. A dimension not only of sight and sound, but of mind. A wondrous journey into the nature of reality. Next stop, the smAsho zone. Looking at the sun at 193 angstroms. We see a coronal hole associated with the South Pole. And we got a pause button on the screen there for no reason. And as one active region sets, another rises in the east. Let's take a closer look. Here's the 171 angstroms view. First, we'll take a look at this rising active region. Is it a sunspot? We're going to keep you in suspense. Also, we have a little tornado action here going on in the northwest. No sunspots, except perhaps that one that's rising. And there are the magnetic lines at 335 angstroms. Moving on. Next, let's look at the real-time solar wind, and we see just a couple little slight fleeting signals with those coronal hole regions, the South Pole coronal hole area. No ongoing connection with the coronal holes magnetically speaking. Solar wind density is down to 4.71 protons per cubic centimeter. Solar wind speed down to 364 kilometers per second. Next, we'll head to spaceweather.com. Great site full of useful links. Please explore it in your free time. 10.7 centimeter radio flux remains at 70. Get some more in-depth data here at spaceweathernews.com. Tiny bumps in the X-ray flux, but basically still flatlined. Magnetometer is actually looking pretty steep here. We'll be looking at the Gong 2 momentarily. KP index is at 3. We're showing a little drop in the electron flux before it comes back up here at midnight satellite time. No real charging hazards for spacecraft. And there's the F2 ionosphere layer, looking as it has for weeks. Auroral forecasts are weak. And here's the Gong 2 synoptic ecliptic field plane plot. The active region we see rising is this one right here. Probably is a sunspot. It looks very defined. We're not going to worry about that too much. More interested in what's going on in the magnetic environment. And so, looks to me like the spikes we're seeing in the magnetometer are caused by these perturbations right here. Here's the last frame. Keep in mind this data is an hour and 43 minutes old. So what we're seeing there on the GOES magnetometer is the snapping across of these areas. We won't see a big spike. We'll see a small spike and then basically continued weakness in that magnetometer reading until the crossing of the heliospheric current sheet, and then all bets are off. And here's the top view of the ecliptic field plane plot. Moving on. Next we have your geospace magnetosphere movies here. Here's the velocity. By now, most of our regular viewers should be able to have some clue of what this is going to look like based on the solar wind data. And here's density. See variations in the solar wind coming in there from the left. And Earth's plasma spheres are looking pretty dense. I mean, pretty diffuse right now. Not very dense. And here's the pressure as we look at daily. Quite a similar amount of pressure on the magnetotail and the leading edge. I don't know why it always has to refresh on this. It just does. There's your very uniform magnetospheric pressure. And let's look at something a little closer to home here. Geospace ground perturbations. Looking at the polar view, obviously. Not a lot of perturbations at all. A little bit going out toward the Indian Ocean from the South Pole. Otherwise, not a lot happening. Let's look at it from the global perspective here. You should see a little bit of magnetic leakage there into the Indian Ocean, as we do daily during this pole excursion, pole flip, magnetic excursion, whatever you want to call it. Next, how about a visit to quakes.globalincidentmap.com? We are experiencing a huge earthquake drought for 6 and 7 plus magnitude earthquakes. These are the areas who should be on watch. For a 6 or 7 magnitude earthquake, as again, we are in a drought, and we could be seeing a magnetic connection to that southern coronal hole at any moment. Let's check the last 13 hours. So we see a 4.9 in Japan. We see a 5.0 in Tonga. Look at both of those on the map, I guess. There you go. There's the one off of Japan. And there's the Tonga quake. See right on the corner of the earthquake watch area there. See a 4.9 in the Bay of Bengal. That's a pretty rare quake there. By the way, this is the possible one of Earth's geomagnetic poles in the event of a pole flip. Just saying. .1 off the coast of Oregon. Another rare event there. At least not at a deep depth. .5 in the Philippines. At a depth of 78.4 kilometers. There's the location of that one. And no other quakes of note. How about volcanoes? We got a little volcanic uptick here. We see Shivaluch back to producing a 15,000-foot ash plume. Sakurajima, 5,000-foot ash plume. Dukono, 7,000-foot ash plume. Continuous emissions. Here's a new one on the list. POAS in Costa Rica. Persistent low-level ash emissions and incandescence, suggesting new lava is erupting. This is the first strong activity since the vigorous 2017 eruption. Unrest has been slowly increasing for the last few months. Also, we've got Reventador at 15,000-foot ash plume level. Sabancaya, probably still erupting, just unable to detect. And Planchon Peteroa. Volcanic ash not identifiable from satellite data. Moving on to our daily segment, Zooniverse.org. It's the world's largest and most popular platform for people-powered research. The research is made possible by volunteers. Why? Well, we've got too many galaxies. We've got so many galaxies that there are hundreds of billions of them, and we're having trouble classifying them. These need visual analysis, so make yourself a login at Zooniverse.org. So beyond classifying galaxies, you've got other volunteer opportunities available here also. Check it out, read all about it, Zooniverse.org. Get yourself published in an astronomy paper for classifying galaxies. So you head to the Galaxy Zoo section and classify a galaxy, which we will do right now. Check it out. We're going to save that for posterity. And we've got a pretty irregular galaxy there. So what do we have? Features, or a disk. Is it an edge-on disk? Not an edge-on disk. Does it show a bar? I'm going to have to say no on that one. Is there a spiral arm pattern? Not really. Just really irregular. Is there a bulge? Yeah, there's a bulge. Let's say large. Is it merging or disturbed? I would say yes, merging. And do we have unusual features? Well, we sure do. It looks like we've got irregular, dust lane, and overlapping. And there you have it. That galaxy has been classified. Here's the next one. We're not going to do it, though. We'll leave that up to you, the viewer. Speaking of the viewers, yeah. Turns out Mars 1 is dead, but it was doomed from the start. We're talking about the financial aspects of the Mars 1 project. It ain't happening. Now, as if it wasn't a bad enough idea to go to Mars during a time of solar minimum, exposing the astronauts to a fatal amount of cosmic rays by the time you get to Mars, much less have the ability to get back. Well, Mars 1 was a one-way ticket anyway, as if somebody wants to just go to Mars and die there. But in any case, the nonprofit aspect of this project has filed for bankruptcy. We'll leave links to the article that we found at extremetech.com. Next, let's look at Science Alert, otherwise known as nonsensealert.com. Check it out. Polar bears are invading Russian towns. And guess why it is, folks? It's because of climate change. This article picked up by Nonsense Alert from the Washington Compost. Yeah, so polar bears are starving and they're terrorizing this town. Why? Because it's too cold for them to find food, because the Arctic is frozen. And when the Arctic is too cold, polar bears can't get through the ice to get to seals. That drives them south into populated regions. It's not because the sea ice is melting, folks. If the sea ice was melting, they would be up in the Arctic eating seals and getting fat. Instead, we have a frozen Arctic where people are scared. Regional officials reported in their statement they're frightened to leave homes and their daily routines are broken. Parents are afraid to let children go to school or kindergarten, as they should be. These things will stalk you in the wild for months. We'll leave links to this nonsensical article and hope that people understand how polar bears work before they keep writing article after article about them and making no damn sense. On a related note, let's go to Polar Portal here, polarportal.dk, and let's see the ice volume. Let's see. Oh my gosh, looks like it's right in the middle of the multi-decadal average there. Doesn't look too melty. Let's see the extent and thickness. It's looking pretty icy to me. What do you think? Let's go to Global Cryosphere Watch. How about total snow mass for the Northern Hemisphere? I'll just leave this on here for like a solid minute so it sinks in. It's so hot in the Northern Hemisphere that it's cold and covered with snow and ice. By the way, this average here is for 1982 through 2012. And you see where it is. There's where it is, people. How long until this website's taken down? Thank you, subscribers. We're at 1,002 now. Looks like we picked up a subscriber while making the video. How about that? And we're going to do a little weather tutorial here to help y'all people out in the Northeast who are trying to figure out when it's going to stop raining, start raining, snowing, wintry mix, etc. So let's start out by looking at the U.S. Doppler radar map. Compliments of AccuWeather.com. And we can see this storm in the Northeast is really stagnating, and we have this long line of severe thunderstorms, it looks like, heading all the way down into the Gulf of Mexico. Now, we're located in eastern PA here, so it's a perfect opportunity to show you how to look at more data and figure out what's going to happen above your head. Now, we will leave links to these sites. Let's just give you an example here of what to do. So, click on the Northeast. You should view these as animations, people, not as still images, so that you have an idea what's going on in the motion of the atmosphere. There's the Northeast. And you can see the storm is stagnating. And this is an indication that you need to look at the water vapor map to figure out what's going on in the upper level. Because Doppler radars are ground-based, and they do not always show you enough information to make accurate predictions. Now, while AccuWeather.com does have a water vapor map, and it is good, it will give you the information you need. We're going to look at the NASA GOES water vapor map because it's got a little higher resolution, but we will leave links to both as they will assist you in predicting the weather for you. Now, here's the NASA GOES shortwave infrared radiation satellite. Since it's dark out, we can't see the clouds with a visible satellite, so we're going to use this one to show us what's going on in the cloud layer. You can see the overwhelming flow for this area is almost entirely due east because of the location of the low. Let's see how that translates into water vapor. And there's the water vapor map. Keep in mind, folks, water vapor is often invisible. The only time you can see water vapor is if it has condensed and become a cloud. Otherwise, water vapor in the atmosphere is invisible and will not show up on the Doppler radar. Doppler radar are ground-based systems that are measuring vertical motion in the atmosphere. So, again, there's the Doppler. There's the shortwave infrared from the NASA GOES satellite. Links will be in the description. And there's the water vapor satellite. Also, we will leave links. And there you have some ideas on how to figure out the weather when the Doppler is not giving you the information that you need. Because we want our viewers to be able to predict this stuff themselves and not rely on anybody. Remember, when you're listening to a radio broadcast or a television broadcast talking about the weather, they have a listening area or a viewing area. They need to predict for that entire area. That's not necessarily going to be in your best interest. You want to know what's going to be happening, where you're going to be, where you currently are, etc. Speaking of where you currently are, you're orbiting this lovely yellow dwarf here. We've got some big-time filaments going on. Let's take a closer look. Here's the one in the northwest, which is quite a hotbed of activity. Check it out. And here's a bunch of stuff going on the eastern limb. Filaments preceding this active rising region. In any case, we'll be doing it all again tomorrow, folks. Thanks for tuning in. Thanks, viewers, subscribers. If you haven't subscribed and pressed that like button, please do so. Leave us a comment. We will be doing a 1,000 subscriber special soon now that we've reached that milestone. We really appreciate your support, your views, your PayPal contributions, your Patreon subscriptions. Good stuff is happening. Remember, when you're staring at filaments, don't drink. And if you drink, stare at the filaments. Just don't drive.